to the God Conclusion. I'm your host, John Leonard. Greetings and welcome to another episode of the God Conclusion. Today, my guest is my friend, Tony Zoltai. Tony and I have been friends for, I want to say, at least a decade or more, long before I wrote the God Conclusion. And as an atheist, I asked him to read and review the book, and he very graciously did that, and we're going to discuss his review today. So welcome, Tony.
Thanks, John. Appreciate the chance to interact with you face to face. We haven't done a great deal of that, and I'm happy to provide my commentary. Maybe one little bit of introduction. Tony Zoltai, I'm an unbeliever. You mentioned I'm a known atheist. Just to clarify that, I'd be around the number 6 on the Dawkins scale. Like Richard Dawkins, I'm not asserting a strong position of there cannot be a God. I'm saying I could be wrong. For practical purposes, I'm not assuming that there is a God. And always open to persuasion and discussion, and hopefully in a fair and appreciative way.
I certainly did appreciate the review that you wrote. I posted it on my blog this morning. I thought it was excellent. And there were a couple of points that I obviously would like to discuss with you. The first of which being Fred Hoyle's Junkyard Tornado. Before we actually get into the discussion, I would like to apologize to you because I really felt like I missed something in the translation of the book that to me seemed fundamental, but it's not something that you picked up on. That is, I was trying to come up with a dichotomy or a binary way of looking at the existential questions involving the universe.
Okay.
And for a while I went with God or good luck as the two alternatives, and that just really was unsatisfactory. And then I finally settled on planned versus unplanned, or directed versus undirected. And
yes,
in those two contexts, it's a very holistic approach. Either the entire universe was planned and then everything within it is planned, or everything, including the universe, was unplanned and was the product of or aimless processes as opposed to intentional processes.
Sure. Yep. Okay. Yep.
Okay. So in that context, when first of all, for the benefit of our audience, I'll just briefly recap the Fred Hoyle analogy that we're discussing, the tornado and the junkyard, which is the origin of life. He said, to imagine that happened by chance is like imagining a tornado ripping through a junkyard and at the end of it, putting out a fully functional 747 airliner. And it's a very tongue-in-cheek, very typical of Hoyle to come up with an analogy like that, because he's the guy that coined the term the Big Bang Theory. And people don't realize he was mocking the theory when he came up with the term. He was saying, oh, everything just exploded in a big bang. And then because he was an advocate of the steady state universe. And it was because of Hoyle's research into the science that led him to, in my opinion, it's not written anywhere, but in my opinion, he converted from being a rather staunch atheist to being something of a deist or an intelligent design advocate by the time he died, because he looked at the origin of the universe. He says, okay, if the universe hasn't always been here, then we can't assume life has always been here. And that creates a problem of how you get a living cell from inanimate matter. And when I dismissed, as you put it, the Dawkins argument of the designer must be more complex than the design, I'm conceding the point. I agree completely that God, by definition, must be more complex than what he is creating. Or, and again, in the book, I did another disservice to you in that, and it might have been because of our longstanding friendship that I'm a Christian, that you thought that the book was written from the perspective of advocating for Christianity. And I bent over backwards to not mention the Bible in this book. The only chapter in which I refer to the.
You
Go ahead.
no, you're quite right, and the your deliberate avoidance of getting into biblical argument, I think, is one of the things that recommends this book to a general audience. I think I've done you a disservice by not pointing that out in my review. That actually is one of the persuasive things, that you're not talking about Deuteronomy XYZ says this and therefore. You're not arguing from that point of view. You are arguing for the proposition that there is a God. Whether on top of that a person accepts teachings of Christianity or Islam or any other theistic framework, you're not getting into that. And I think that's a valid point to make. So I don't think you owe me an apology at all. The point about Dawkins's ultimate 747 argument, where he goes back on Fred Hoyle, going, yes, the complexity of life demands an explanation, and a single event of random assembly doesn't account for it. Explaining it by a designer makes a framework that has a designer that must, by everything that we know of, be more complex than the design. And therefore, you've shifted the question of where does the complexity arise from to an even higher degree. So hence the ultimate 747 argument. I didn't realize that your treatment of that argument was essentially conceding the point that, yeah, fair enough, yeah, God must be more complex. So when you say, so what, I didn't realize that what you, in the book, you where you go, excuse me, but so what in relation to this? So God must be more complex, but what does that mean? So what? Apologies for misunderstanding that.
No worries. As the author, I always take responsibility for failing to articulate my point in a clear and concise manner that communicates what I'm trying to say so that there can be no possible misunderstanding. So I always put the fault on myself when I fail to deliver the point that I'm trying to convey. But I think that's a good start. And I want to say this too. If I didn't sell another copy of my book, I am very thrilled to have gotten you to have read it, because to me, you are the epitome of my target audience. You're fair, you're hard in that you're not easily persuaded. You're not a marshmallow that's going to change with the blowing of the wind direction, but you approach the problem as an analyst with logic and reason, and that's what I appreciate so much. And what I'd like to say is, in the book, I knew fully well that most of the people that I was quoting are atheists. But I wasn't quoting them about their atheism. I was quoting them about the science. I was trying to communicate what they have said about the science, and then applying the logic that I've learned from a lifetime of being a software developer to understanding and coming up with not necessarily the only alternative solution to the problem, but the most reasonable. And so when I look at what Fred Hoyle said, or when I look at what Sir Martin Rees, or Lord Martin Rees, I should say, and Sir Roger Penrose have written about fine tuning and the origin of the universe, I know that they are atheists. I know that Roger Penrose is trying to come up with the cyclic conforming cosmology where he eliminates the Big Bang as a problem by making it this endless cycle, what I call kicking the can down the road, of you've got the problem of we know that at one point this universe had no stars, no galaxies, not even a single atom. So that is a true definition of nothing, no material thing. And before that point, we can only speculate. But we know that point existed. And that point creates a huge problem, in my mind, for a naturalistic worldview. Because the whole problem of something out of nothing, and I've talked to a number of atheists about this, and they like to cite Lawrence Krauss's book, A Universe from Nothing. And I go, it's in the title. And he goes, and then the response comes, but when he said nothing, he didn't really mean nothing. He meant quantum foam instead of no thing.
The quantum vacuum, yes.
To me, it's anything but God. So I say, okay, don't even call it God. Call it supernatural intelligence. But there seems to be an order that began at the moment t equals 0. There was an order already in place of the precise combination of elements that are to be manifested in this universe. It's already scripted. I like I said in my book, I tried bent over backwards to not invoke the Bible. But when I look at the Bible and I look at the explanation of the Big Bang, I'm going, what is everybody missing here? The universe started from nothing. And then the Bible says, in the beginning, God created. It's saying the same thing. It's saying there was a beginning. And before that, there was nothing.
Could even take it further than that, I think, in that of the beginning, certainly the Gospel of John has something to say about this, where, and I'm going to quote it the way that it is in my mind, which might be different from other translations, but
in the beginning
was the
and
Word,
the Word was God, and the Word was with God.
Yes. Now,
beautiful.
I believe, and I'm no scholar of Koine Greek, but in the original Greek, this is the word is logos, which also means, by metaphor, things like reason and logic and reasoning. If you try to apply that to a scenario where you have a beginning of an entire universe that is ordered according to certain principles and certain laws, certainly logos, the abstract idea of reasoning that things follow from other things in a logical, derivable, discoverable way, that seems to be expressed there as well. So you could probably go even further than here's a plan for how things will unfold. If anything, the Gospel of John goes even further in saying from the very beginning there was a set of rules that reason is a part integrally of what is.
I don't want to get into a situation where I start thumping my Bible. I want to pull back, if you will, from the biblical connections and go back to the scientific evidence. Do you have any issues with what I called the existential scientific evidence of fine tuning, inflation, the comments that I had in regard to the origin of the universe?
John, I'm going to have to ask you to repeat that. I've had all sorts of problems for the last 30 seconds or so. So I got little bits of what you said in relation to the Big Bang and fine tuning.
Yeah, what I was trying to say is I want to, because the book doesn't really get into the biblical connections between the Big Bang and the origin of the universe to the Bible. I'd like to turn our focus back onto the scientific evidence. And my question is, do you have any objections to fine tuning and inflation and the evidence that I presented in terms of the origin of the universe or the Big Bang?
Right. You're asking about the fine tuning argument. Now, I don't have a strong rebuttal of that. So let me just explain what I mean by that. To me, the fine tuning argument, the point that we have settings or numbers or parameters that don't seem to be inherent in any or derivable from any law of physics. They just seem to be the way things are, and that these numbers are in agreement with each other in such a way that complex physics, even more complex chemistry, and then even more complex biochemistry can arise, can operate. Sorry, I delete the arise. I think that's one step too far. That they can operate. For example, they are tuned. These settings are related to each other in such a way that all the processes that make something like the functioning of a human body or a human brain possible are in fact operable under these laws of physics. And I think that's probably one of the most powerful arguments in favor of intelligent design. The only cogent response that I've heard appeals to the possibility of other universes. It runs like this, and I'm not necessarily endorsing it, but I just want to sketch it. If it is the case that all of these numbers, and there's only a small number of them, there's maybe one or two dozen that we know of, if all of these are in relation to each other in just such a finely adjusted or finely defined way that it just so happens that our universe permits complex life, what that calls for is the possibility that either it must be like that any universe that could ever possibly conceivably exist must conform to those numbers, or it must be the case that there is a conceivable possibility of other universes that do not conform to those numbers and in which creatures like us could not exist. The point there is, if there is a possibility of other values for those settings, then in any other universe that could have existed, we wouldn't be here to ask the question about cosmic fine-tuning. Therefore, if there is a possibility of other universes, then the only time that the question would be asked would be in a universe that has the right settings. And if there are not other settings, then we are back to the same possibility where we have a single universe, there is a single conceivable universe, and it either just happens to have us in it, or there is no other settings that are possibly attainable by a universe for reasons we don't yet understand. I've drawn a long bow here. I think the fine-tuning argument is easily, to my mind, the strongest and least refutable point in favor of intelligent design. The only way to push against it is to speculate about the conceivability of other universes. Now, there is a lot of physics, a lot of theoretical physics, I must say, theoretical physics, that operates on a multiplicity of either actual or potential universes. There is even some physics that is looking for some evidence of those other universes in physical observation. Now, I'm nowhere near good enough as a physicist to comment on that, but you occasionally see headlines about we have just found what could be evidence of a potential parallel universe interacting with ours. And It relies on measurements of cosmology, microwave background, and all of these kinds of things. And I really can't comment on it other than to say that's all great, and we have mathematical frameworks that permit that sort of interaction to occur. Are they correct? We don't know. A lot of this theoretical physics is problematic in that there are predictions there that are not necessarily testable, and certainly not testable from our technology right now. It is possible that they'll never be testable. The very counter-argument is based on the multiplicity of universes, which is something that we only speculate about. So you're building a counter-argument to the fine-tuning argument from something that you don't have evidence for, and some of the stuff that you have built is not even in theory testable. There are frameworks where separate universes, if they are conceivable, don't interact at all. There are physical limits. They are physically incapable of influencing each other at all. In which case, if there is such a set of universes out there, they may as well exist as far as we're concerned, because we can never in any way interact with them. All of this makes the counter-argument to fine-tuning a problem. At its very best, it's still very weak, very hypothetical, very theoretical, and based on a whole bunch of speculation that, whilst it's reasonable and it is educated and derived from stuff that we have observed, there's a lot of steps of derivation before you get even to the assumption that then allows you to come back and go, here's my counter-argument to fine-tuning.
I have what I would call a love-hate relationship with the multiverse hypothesis. The traditional multiverse hypothesis, to me, is just an evasion tactic to come up with a solution to the very highly improbable problem of fine-tuning. You posit an infinite number of failed universes that are created concurrently with the one working universe that we happen to occupy.
It's already failed. Failed is perhaps too definite a word. It could be that all of these universes, as much as they don't contain any life, and certainly no intelligent life, could be out there and actual and operating in their own way. Failed would only apply to a universe that is intended for a particular purpose and then fails to fulfill that purpose.
And let me push back on that, because we're basically two novices trying to have a conversation about a very complex issue, but that's not going to stop us here. But if even one, it's my understanding that if one of the values, which is, I want to say it's 0.0000000001, and if that was off by minuscule value,
yep,
in one direction, the entire universe, it would exist, but you wouldn't be able to create any elements. It would just be
yes,
a void. Yes. And then
yep,
if it's one minuscule degree in the opposite direction, everything just implodes on itself and this never even starts. So
roughly how I understand it as well, yes.
The idea is that, and you touched on it, the anthropic principle of having observers in the universe able to look and see, this is what we can determine about the universe we occupy. But to me, the multiverse hypothesis, the traditional multiverse hypothesis, still has the fatal flaw of it doesn't have a cause. It doesn't say what caused the Big Bang and what caused all of these other universes to get kicked off at 13.77 billion years ago or whatever it was. So to me, the standard or the traditional multiverse hypothesis is basically useless. But I came up with a version that is useful from my perspective. And that is that, and this borrows from Sean Carroll's multiverse theory or hypothesis,
Okay.
where there's a static parent or eternal universe, and our universe is a child off of that static parent that has
Okay.
always existed. And so that to me is a working model if you say that there is an eternal realm. You can call it heaven, or you can call it nirvana, or whatever you want, where religion is independent, but there is a eternal state in which eternal entities can exist, and those entities have the ability to start a universe.
Okay.
And according to the traditional biblical perspective, it's when God speaks and says, "Let there be light."
Let there be light.
And I'm trying to play it both ways. I'm saying let's get away from the Bible and talk about the science, but then every time I talk about the science, I can bring it back and connect it to something in the Bible. And the same as with inflation, the Bible describes inflation. The Bible says that God stretched the heavens and continues to stretch the heavens today, even today. That to me describes cosmic inflation to a T. But I'm never going to convince a scientist of that. I might convince some random guy on the internet I'm just talking to as a friend.
Okay. Look, what you've outlined, the framework where there is a universe in which eternal things can exist, and there are ways for influence or power from that universe to create a lesser universe such as ours. I don't think that's necessarily a poor idea. I would perhaps caution against ranking that in amongst the multiverse theories. And I think that the distinction that I would draw is power of inference. When a theoretical physicist formulates, and I'm speaking only from my limited experience of the academic realm, between the time that God Delusion came out and now, God Conclusion came out, I do beg your pardon, and now I've published my first peer-reviewed paper, so yay, I'm now a scientist.
Awesome. Congratulations.
Thank you. Thank you. It had nothing to do with either biology or cosmology. I'm still a complete novice in both of those areas. But I have a little bit of experience of the academic publishing process. So when a physicist starts talking about it is a possibility that there exist other universes, and here are some equations that would describe what may be possible in those universes in this framework. That's a very theoretical thing, and there are lots of things there to put a hook in and go, yes, but how do you know this and how do you know that? And they would respond, we know this because we have equations in quantum physics, we have Schrodinger's wave equation, we have matrix mechanics and all of that stuff, and we can derive mathematically that if that is the case, then this is at least conceivable. An eternal universe, I'm not sure how that would, an eternal parent universe, if you like, I'm not sure how that would rank or how that would fit into any of those frameworks. It is possible that there is a framework that permits that. Certainly the eternal steady state universe of Fred Hoyle, as he originally had it, would fit that. The Fred Hoyle model itself had a question about, yes, but what about entropy? What about the second law of thermodynamics? I'd be a bit hesitant to assert a parent universe model as being as solidly derivable from what we know as something like the many worlds interpretation of quantum mechanics, where every time that anything happens on even the most minuscule scale in an atom, there is a multiplicity of universes spawning forth from that point, which I have all sorts of intellectual issues with that model as well. but I can't deny that mathematically, yes, you can build a mathematical model that makes sense, that results in that. How real that is, I can't even comment.
Well, I would like
I do want to just come back to one point I made. Fine-tuning, cosmic fine-tuning, is, to my mind, easily the strongest argument that currently exists in favor of intelligent design that I have seen.
I like that, of course. I would say also that the problem of the origin of life is as complex in many respects and could be unsolvable. Now, taking a step back to what I had briefly thrown out there as the multiverse hypothesis, I have to stress the emphasis is on the word hypothesis because none of this stuff is provable. It'll never be provable. You will never be able to prove the existence of anything outside of the universe we currently occupy. That's a parallel universe, a multiverse, anything outside of our universe, we're never going to see or be able to prove in any sense of the word. One thing because I tried not to belabor the point too much on natural selection and Darwinism, but you did say that I referred to the evolutionary idea of common descent as being all things related through sexual reproduction. And you're right. You're absolutely right. Reproduction is the word that is operable in that because it's say asexual or sexual reproduction. The only reason that I specified sexual reproduction is because most people don't really think of single cells organisms as being creatures and that sort of thing.
Probably fair.
But from that standpoint, that kind of lends some credence to my argument that Darwinism as a whole doesn't really make sense because the very first organism, according to abiogenesis and logic, says it had to be a single-celled organism, probably phytoplasts or something like that, that could reproduce using sunlight and didn't need any food sources that could consume chemicals. And it reproduced by cloning itself. So why would any organism develop a need to pair up with another organism to reproduce, making reproduction infinitely more complex? What's the point of that?
Okay. Again, I'm no biologist. I can offer a potential answer to that. So, first things first. You are right in that if there was a process of natural abiogenesis, of chemistry operating in the way that we know chemistry to operate now, and that a long chain of reactions produced life, at some point in that process, you had to have something that you could recognize as a cell, possibly the first cell. So an entity that is encapsulated in a membrane of some sort, and it contains all the bits and pieces that it will need, or that will lead to it creating a copy of itself, perfect or imperfect, to create more of these encapsulated entities that we now consider cells, thereby starting off the whole process that we infer has led to us, or at least that the evolutionary part of our society considers leading to us. Your question is quite apt. We observe sexual reproduction, certainly in most of the animals that we consider reptiles, mammals, in fact, vertebrates of any kind. Also in invertebrates, in insects, in worms, in all sorts of other forms of life. This theme of there is male and female and you need one of each to reproduce occurs. There is this asexual mode of reproduction, which is also present in complex animals and complex plants, but perhaps less well known. You would be familiar with some of the examples. There are some fish that can switch between sexual reproduction and asexual reproduction. I believe some frogs can do that. Certainly, once you get down to the level of colonial organisms or single-celled organisms, even simpler, you are reduced to asexual reproduction. There is no male and female single-celled bacterium that I know of, at least. And again, I'm no biologist, there could be exceptions. But bacteria simply reproduce by growing large enough to pinch off a new bacterium, seal off a division between the two compartments, between the two membrane enclosed cells, and suddenly from one thing that has two bulbs with a narrow bit, that narrow bit gets pinched off and suddenly you've got two, and they each have all the bits that they will need to repeat the process. Asexual reproduction, it leads to cloning, as you mentioned. Most of the time, the genome that is present in the two daughter cells is identical to the genome of the parent cell. Obviously, mutations can occur, but most of the time, that mode exists. The question is, given that is a perfectly viable way of reproducing, why would life need sex? The answer, and again, I'm drawing a long bow, but I'm coming back to it. The reason why sex is useful is it remixes things that are already viably part of a genome of life, or of that form of life. So, for example, let's take something simple like worms. The one that's studied quite a bit is C. elegans. The C is an abbreviation. I think I'm not even going to try to pronounce the Latin. It's a very simple worm. It's about 1 millimeter long. We know a lot about it because it's an ideal subject to study. And it does have sexual reproduction, slightly different from what you would normally think. It's not as simple as male and female. There's a hermaphroditic version of this worm, but it essentially reproduces sexually. The whole thing is made of a few hundred cells. A fully grown specimen is only a few hundred cells. The reason why it is good for an organism like that to have sexual reproduction is it allows more new combinations to possibly be perpetuated. An example, let's say we have a worm that is not reproducing sexually. If in that reproductive process that we talked about, the original cell from which the worm grows, the embryo if you like, has an error in its copying of DNA, that error could be beneficial, or it could, and much more often is, a problem. Actually, sorry, not much more often is a problem. Much more often is neutral, but it could be a problem and is more often a problem than an improvement in relation to its environment. Let's say we have a mutation and it's probably going to work against the organism. If you have a sexual match where you combine two entire genomes, each of which has its own variations of various things, its own alleles of each gene, what you're doing is creating new combinations, most of which reuse bits that have already proven themselves. And by proven themselves, I mean they have been good enough to survive to this point. All of these alleles are at least functional enough in their environment to contribute to a living organism. And then you have some new ones that may or may not be useful. If you have a combination of two sets with a random selection of which gene is coming from the mother, which gene from the father, you have a good way of propagating a newly created mutation and giving it a good environment to survive in, if it is in fact beneficial. If not, then selection will weed it out. Perhaps the best way to summarize that is sex gives you a way of remixing known solid DNA into possibly new combinations that then might lead to stronger lineages down the track. Why would it arise in the first place? And this is a question that biologists like Dawkins would ask. Why would that arise in the first place? How would that arise in the first place? How would you get this split where some individuals are definitely male, some definitely female, and it's only the match of those two that gives you the way forward? If you look at some fungal reproduction, it gets more complicated than male and female. There's a good number, much larger than two, of reproductive groups. And what you need is, you need to have cells from different reproductive groups to create new fungi. It's not as simple as male and female, but you do need them to be from two different groups. And I think, again, I'm no expert, I think it might even be that there are some rules about which groups are compatible to create new fungi and which are not. That's a complicated scheme. You can see how that might arise from a diverse population of fungi that benefit from exchanging known good DNA in various novel ways, but it certainly would benefit from being simplified to male and female. The male and female simplification could be a further adaptation out of a situation where you've got these reproductive groups, not necessarily, you could say multiple sexes, but certainly groups that can't by themselves propagate. They need the other groups, or at least one of the other groups, to be present. So there is, and I'm again stressing I'm no biologist, to me there is a conceivable way for that to arise in nature. Even before sexual reproduction, we know in bacteria there is a mechanism of exchanging plasmids, of exchanging DNA and absorbing DNA from the outside that leads to new genetic combinations forming. Clearly, in a world where that isn't the case, as soon as your bacterial lineage encounters an environment it can't cope with, it dies out. If it does have that ability of importing DNA from elsewhere, it has at least a fighting chance of maybe that DNA will actually lead to surviving descendants. So I think if we take the step of perfect cloning reproduction to cloning reproduction with potential mutations, to reproduction that also permits importing DNA from the outside, as we see in bacteria in lateral gene transfer, to the fungal idea of multiple different groups that can exchange DNA between themselves, to simplifying that into two sexes, I think you have a reasonable, at least plausible, way in which sexual reproduction can arise. And I know I've taken a long time to answer the question, but I hope I have gone at least some way to answer it.
No, it was a very interesting answer. And now I'm going to push back again because as I see it, you are committing the logical fallacy that every biologist on the planet does. And that is, you want to separate the origin of life from the diversification of life. And to me, the problem itself is life. It's the origin of life and the existence of modern life. And we're trying to understand how that could happen. So let's go back to the beginning in an unplanned universe. And you've got all of these inorganic materials that are floating around in your warm, shallow pond that Darwin visualized. And the cell makings are trying to form themselves. We'll just throw out, for the sake of argument for a moment, that no one has ever created a cell membrane de novo. We don't have any idea how cell membranes come to exist, and we don't know how lipids and enzymes could have evolved at the same rate as the other components of the cell so that the first cell could form. And so if you listen to the chemist, they're going, yeah, these are problems that are not easily solvable. They may never be solvable. And getting back to Fred Hoyle's tornado in the junkyard analogy, I don't know that Hoyle ever did a calculation on what it would have taken for the first cell to form. But I do know that from the numbers of fine tuning, that the odds against this universe forming are 1 in 10 to the 300th power. And I also know that the number of atoms in this entire universe is only 1 in 10 to the 80th power. So we're talking about numbers that truly boggle the mind. I mean, we're not talking about 1 in a billion or 1 in a trillion even. We're talking about numbers that, Googleplex kind of numbers, where it's difficult to comprehend what the numbers actually represent.
Yes.
And Fred Hoyle said that the odds against one functional protein forming by chance is 1 in 10 to the 40,000th power.
Mm-hmm.
And to me, at some point, you have to go back to is the universe planned or unplanned? You've got, in the unplanned universe, you've got numbers like 1 in 10 to the 300th power, 1 in 10 to the 40,000th power, 1 in 10 to the 124th power. Those are all representing improbabilities of this universe forming by chance.
Okay.
As opposed to the planned universe, it's 100% probability because you have intelligence driving all of the decision making and the precision of this universe. And the fact that we can express everything about this universe mathematically tells me that order is supreme. I mean, you do that, but I mean, we've got Fibonacci spirals and Mandelbrot's fractals, and those are mathematical equations that you can plug in the values and plot them out to infinity, and they draw spirals in the galaxies.
Sorry, I didn't mean to cheapen your point. You're quite right, and acknowledged within the scientific community is that mathematics is an unreasonably good way of understanding the universe. Why is that?
Exactly. No, we can't have any problems here, Tony. You're my friend, and so you can do no wrong here. We're having fun. But I'm going to try to get a little bit further into some of your criticisms, or not criticisms, but I use the words random chance far too often.
Yeah.
And I probably should have said random processes. But again, the word random is the more important word in this because it means the unplanned versus the planned. And now, in terms of the moral argument, I couldn't really tie that into the scientific evidence, but it is important to note that we derive all of our morality, whether we want to admit it or not, we derive it from these religious origins of the Hammurabi Code. I don't know if that was necessarily religious, but the Ten Commandments and these other religious edicts that they've been codified into law. We don't rape, we don't murder, and that sort of thing, because we know that is inherently wrong. But if there is no controlling legal authority, as Al Gore famously said, or there is no form of supernatural intelligence, then there is no legal justification, no moral or logical justification for saying that when grandma dies, you don't eat her for dinner.
The moral argument is actually a really interesting one. Can we just rewind a little bit to the close of the previous section? Because I just wanted to make one point that I think is quite important as we wrap it up. Your statement was that for life to develop anything, including sexual reproduction, it needs to start. And for it to start, it needs to have an environment in which it can start and in which it can survive. And that only happens in a universe that permits that by its laws and settings and relations of its parameters. And the unlikeliness of a universe like that is beyond astronomical. It's implausibly unlikely, beyond even the meaning of implausible. Two things on that. One is a point of epistemology. The way that, so you're right in that for life to develop and become more complex, it needs to begin first. And for it to begin first, we need a universe in which it can begin, even conceptually, even if we posit an unguided process for the parameters have to be there for the process to start and be in and proceed. Epistemologically, though, what do we know? We know from observation that life is in existence. Life continues. It seems to be more or less stable unless its circumstances change very suddenly in a way that life can't adapt. We know a lot about how life handles change by processes of learning, processes of adaptation. There is a prerequisite, which is that life started at some point. But I think your point that it is a fallacy to not pull those things all together is a fallacy only in the metaphysical sense if you demand an explanation for everything. If you want to go from the knowledge you have to more knowledge, you absolutely must take it step by step. You must be able to say, I know this, I've got some new evidence and reasoning, so I'm going to take a step further to know this, and I'm going to claim this little bit of extra knowledge without being obliged to have an explanation of everything. And I think this is something that is a fundamental difference between the two camps of believers and unbelievers, where I hear a lot of believers go, but if you can't explain abiogenesis, or if you can't explain fine-tuning, or if you can't explain why there should even be a multiverse, then you've got nothing. Then all of evolution falls, Darwin labored in vain, we're back to there must be a God. And I think that is mistaking the point of science. The whole reason why we have science and why science is not an easy thing and why it's demanding and why there's peer review. And peer review, by the way, is brutal. Just saying.
You have experience with
it. No bitterness there at all. Right? The reason why we are gatekeeping what we claim as scientific knowledge so damn difficult, so damn hard, is because we don't want to jump to a conclusion that isn't warranted. We would much rather go, science was here, now it's this millimeter further in knowledge, and here are all the reasons why that millimeter is a justified claim. Because otherwise, we don't have a solid enough foundation. We don't have a foundation where we can create a mobile phone that, by using relativistic physics and quantum mechanics and material science that took hundreds of years to develop and engineering that took a similar amount of time to develop, we wouldn't be solid enough in our knowledge of all of those things to go, here's your Android. Right? I think there is a distinction between the demand to explain everything versus what science is actually trying to do, which is to build knowledge bit by defensible small steps. The other point, and I did say there was 2 points, the other point was about the unlikelihood of the universe, and you quoted something like a Fred Hoyle figure of the likelihood of our universe is something like 1 in 10 to the 300th power.
That's actually from Roger Penrose.
Penrose, sorry, thank you. When you hear a figure like that, and I would like to appeal to both you as well as the audience that we have, when you hear a figure like that, yes, it does come from an expert. Think about what it means about the framework, about the reasoning that leads up to that figure. For example, and my favorite example in this vein is it's many powers of 10 unlikely that a functional protein would form. The process that is usually invoked, the calculation is usually invoked is, well, it's got this protein has 200 amino acids. For them to form that string of 200, then there's 20 possibilities for each position in that chain. So it's 20 times 20 times 20 times 20 times 20, and it's a combinatorial explosion.
20 factorial.
Yeah, 20 to the power of 200 in this case, but yes, certainly factorial calculations can also enter into it, and then it gets even worse. What that applies to is a model where in your mind you've got a random assembly of amino acids from all conceivable possibilities. So for that probability to be real, you have to have a process where all amino acids can combine in any way they like, just randomly, and just form chains like that. Mathematically, sure, you've got a correct mathematical expression of that scenario. The problem there is that no scientist that works on abiogenesis or any other part of biochemistry looks at it that way, because it is not the case that any chain of amino acids is equally likely to form. That's not how that happens. It's a process of many different reactions happening one after another to create these chains. If I can leave our audience with one suggestion, when you hear a figure like that, especially about DNA or polymers of any kind, proteins, RNA, whatever, question how that 1 in X, where X is a very large number, how that number was derived. Most of the time that I have seen, it is derived from a scenario that no scientist is actually advocating. Applying this to the unlikelihood of a universe like ours starting, I would again ask the question, what is the mathematical expression that is used to derive that likelihood, and on what is that based? Because as far as I'm concerned, if I want to say I roll a die and the likelihood of getting a 6 is 1 in 6, I know that because of the statistics of dice. I understand that. I understand how dice can roll, and I understand that I don't know exactly how that particular tumble will come out, but the likelihood is 1 in 6. We've seen a lot of dice. We've seen a lot of die rolls. We've only seen one universe. To go, there could be 10 to the 300 different ways that the universe could be configured. There could be, but are all of those equally likely? We have a very small population to draw on. We've only seen the one. We don't actually know whether all those others are actually possible. We don't know how this one formed, so we don't really have a good enough way of understanding what could or could not have happened as an alternative. Sorry, again, I've taken up a lot of time. I do apologize for that. I hope I've conveyed at least some of my concern about the 1 in 10 to the X type reasoning.
Absolutely. And I wish you'd quit apologizing, because I'm really enjoying our conversation, and I don't see any need for it. But your comment there inspired me to go back to abiogenesis, or the origin of life. And one of the things that's a big pet peeve of mine with biologists is evolution is a fact. You cannot dispute that it has happened. We know it's happened. And my argument is, well, we don't know it happened because it depends on an unproved hypothesis being successful, which is abiogenesis. And so let's go back, and for the sake of the argument, let's say that we've got all the ingredients that we need to make our first cell. We're going to make an extremophile. So we've got the right number of lipids, we've got the right number of enzymes, we've got a cell membrane, we've got DNA that forms a signature. Okay. And so we've got a functional cell. And it can reproduce by asexual reproduction. It can clone itself. Okay? So where does the information that constitutes the expansion of the cell structure
Yep.
so that it can develop into a multicellular organism. Where does this new information come from if all we've got is one single cell, this extremophile?
Okay. Let me ask you this. There is, and I accept your scenario. We now have an extremophile cell that is capable of reproducing in the way that we understand reproduction, by growing and then dividing into daughter cells, each of which has all the bits, including DNA, to make yet further daughter cells, and we have kick-started life. Where does the information come from is the question. I come back to what I said about science progressing in little steps. Let's say we had traced it back, and we have not. Let's say, but we have identified at least a plausible first cell. Let's say we have done enough science that we can describe what this first cell would have looked like. And then your question applies. DNA contains information. Where is that coming from? Or even RNA contains information, even if you want to go to the RNA world. Where's the RNA's information coming from? Why do you need to know? And I know that's a facetious response. From the point of view of a scientist, you have reached a point where you have further questions, but you don't have enough to actually formulate an answer. A scientist, my view would be, hey, I have achieved a new level of knowledge, which is great. That, of course, throws up a whole bunch of other questions, including where's the information coming from? I don't have an answer. I don't know. And this is where almost every research paper ever written has a section at the end that says suggested further work, or words to that effect. Based on what we have established in this research paper and what we have presented evidence and reasoning for, based on that, here's what we would suggest as further research work to answer some of the arising questions, or even to just back up our conclusion even more strongly. To my mind, if you've established how the first cell was configured, and one of your next questions is how did the information get in there, you have a suggestion for further work. What you don't have, to my mind, as a scientist, is an answer, because you've just arrived at the question. Where is the information coming from? I don't know. Better do more science.
I'm not sure I was clear in the point I was trying to make. I've assumed that we have the information of the first cell. We don't know where it came from or how it got there, but we have that information. It's stored in the DNA of this single-celled organism.
Sure.
But 100 million years down the road, this single-celled organism I shouldn't say wants to, because that implies direction, has the ability to expand its base of information from the single-celled organism into a multicellular organism.
Yes.
And my question goes back to this new information that's coming into this world with only one single-celled organism. Where is this new information coming from?
Okay. That's actually a really good point to clarify, because where does the information into the first cell come from? Where does that information come from versus fast forward a long time, and now we have the arising of multicellular life, possibly even a really complicated multicellular life, possibly even intelligent life. Where is all that information that surely isn't embedded in the DNA of that first cell, because we know that the DNA is different from, say, human DNA.
Can I interrupt you for 1 second?
Yeah, go.
Because you've made another assumption there, in that we're progressing to intelligent life. How do we know that this single-celled organism is not a form of intelligent life in and of itself?
Okay. That one I can answer reasonably directly. We have, point number one, when we say intelligent life, really the only intelligent life that we know that we would all agree is intelligent is humanity. There are levels of intelligence that we observe in other species: dolphins, dogs, chimpanzees, primates of all kinds, octopus, whatever you want to. There are a lot of examples of evidently intelligent behavior, maybe not in the same way as we are intelligent, in that there are a number of intelligent behaviors that they don't exhibit that we do. But when we say intelligent life, we ourselves are the only reference point, really. The question of how do we know that bacterium isn't a form of or isn't intelligent life, given that we understand how our intelligence operates in a physical way. We know that if you give a person drugs to cause their brain into a dormant, if you apply general anesthetic, you don't stop them being intelligent, but their intelligence isn't operational at that particular point. They are in a state where they are alive and stably alive, but they're not doing theoretical physics at that particular point in time. They might wake up and do it later on, but at that time when they're under the general anesthetic, they are not doing that, or at least not in any way that we can discern, and they certainly don't report.
I'm afraid I have to respectfully disagree with you in
Okay.
the point that humans are the only form of recognizable intelligence on Earth, because I
Okay.
can think of numerous examples. One of the more famous ones was there's this Australian cattle dog named Skid Boot. And this dog was smarter than your average 3-year-old child.
Okay.
Just Google when we're done here. Do an internet search for Skid Boot, and you'll see some remarkable videos of this dog. And,
Excellent. Excellent.
but then the better example to me is the acacia bushes in South Africa. And
Okay.
this was in the 1990s. I just recently put it on the Facebook page, a
Yep.
link to the article. But there was these acacia bushes in South Africa, and these local antelope called kudu were feeding off the acacia bushes, and suddenly the bushes started to kill the kudu. But they didn't kill kudu universally, it only killed them in certain areas. And the
Yep.
scientists analyzed this information, and what they found out was that the acacia bushes were getting overgrazed in certain areas of this reserve by the
Yep.
kudu, and the bushes began to produce excess tannins that began to kill the kudu as a self-defense mechanism. And the plants could begin to detect
Mhm.
that they were being overgrazed, and they could put a scent in the air that the other plants would begin to produce these excess tannins, and then they'd kill the next kudu that came and ate them. That to me is showing intelligence, cooperation, communication, and we're talking about plants.
Yeah. 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 I concede that point. Certainly, as I did say that there are other forms of intelligence that we observe in the natural world. I didn't refer to plants, but your point is well made that even plants can be examples of this. So if we say intelligence is any of those things, then certainly that we have many more examples of intelligent life than just humans.
I would say that by definition, life has to have some semblance of intelligence, because it has to know how to feed itself. It has to know how to reproduce. Your humans are not born with this knowledge, but there are numerous
Well,
examples in the animal and plant world of organisms that are able to do this thing from inception, basically,
yes.
without any parental guidance or anything like that. It's instinctive, it's natural.
Okay. All right. Coming back to the distinction between the original information in the first cell versus information that later could arise. And your point is still well made that, well, okay, as life progresses from the original single cell, where is the new information coming in, or was that already in there? And is there a mechanism that life has of importing new information? So to my mind, and I think there is language around this in the general literature as well, but the DNA of any extant, what extent, the DNA of any individual of any species is a series of frozen bits of information that led to its ancestors being able to survive and reproduce. If you look at all of the individuals of any species, but most species in the natural world that are born, that are produced, that are conceived, the vast majority of individuals that are conceived by sexually producing species do not, in fact, leave offspring of their own. The vast majority die without ever either reaching maturity to produce offspring, or having the chance to produce offspring, or having had the chance actually doing it. And then when you consider that the next generation suffers from the same fate, in other words, most of the offspring of the ones that do produce offspring, again, will not leave offspring of their own, there are an awful lot of dead ends in this tree of descent. And I'm not talking about the tree of life in terms of species, just within a species, the family tree. If a turtle has 200 turtles that are spawned from its mating, most of those 200 turtles will not leave descendants. The ones that do will each leave, say, 200, and most of those 200 will not leave descendants, and so it goes on. So the number of individuals that do not, in fact, preserve a genetic legacy is astronomical. Again, we come to this: how many turtles could there have been in 5 generations? And it's a very large number. There are far fewer turtles after 5 generations than you might have expected. What that means is all the different combinations of DNA that existed are cut down brutally to a small number. There is an awful lot of luck involved in surviving long enough, and there's a tiny bit of advantage involved in, at the times when it matters what your DNA is, because your DNA might make you a little bit of a better swimmer if you're a turtle, or a bit of a harder shelled individual, or maybe just able to hide better. At those moments where your DNA becomes the factor between surviving possibly to possibly leave descendants or not, that's an event that is preserved in the DNA of your descendants. So when you look at where is all this information coming from, for example, for the hard shell of a turtle, where is all that coming from? What you're looking at is all the different selection events that occurred in all of the ancestral generations of turtles, whittling away everything other than this one thing. And it could be that there were turtles earlier on that had superior shell mechanics that could have led to much better survivable turtles, but they never got to leave a descendant because, as it happens, they had hard shells, but they weren't able to hide very well. And so what we have is a slightly inferior shell mechanic surviving, but it's still good enough to lead to further descendants. There is an obvious question in response to that, which is, Tony, you're making a big deal out of nothing. Really, what you're doing is, sure, there's lots of combinations of DNA, and only some survive, and the ones that survive leave descendants, and then the descendants inherit. But does this truly explain the really obvious, superb functionality of some bits of biology that we see? Does this explain things like extreme mimicry, where the wings of a butterfly look like the head of a snake, so that it scares off birds from eating the butterfly? That's a really high level of functionality. Can this process really arrive at something like that? Now, my view is that yes, it can, and my way, and this is also why I'm doing the research I'm doing. If you look at a mathematical model of evolution, cut down to a population with randomly mutating copies in reproduction, and with a selection mechanism imposed that rejects most of those mutations, and then repeat this over many generations, it is stunning how closely it can approach an ideal solution, if you know what an ideal solution is. And it's stunning how it can create solutions you never thought of if you don't know what the ideal solution is. So from that mathematical investigation that I'm involved in, I can see that if we are correct, that mutation gives rise to new combinations of DNA, and then DNA is subject to selection because of the phenotype being either survivable or not, and reproducible or not. That mathematical setup, and we come back to mathematical models, you run that long enough, yes, you will end up with extreme adaptation. I can see that being a plausible thing because I've run some of those experiments and I was amazed at the results. I can see how to a lot of people that is just so much gobbledygook, because as the usual response is, yeah, but where did the information to build the computer that you're running your simulation come from? And at that point, I back away, because we're not, if that is the question, then we're not talking about mathematics and what it can show. We're talking about nothing will ever be good enough, because you can always ask the question, as a 5-year-old would, yeah, but why? Yeah, but where did that information come from?
Well, I hope.
The argument terminator for me is, what's wrong with saying I don't know? As a scientist, what is wrong with saying I don't know? There is nothing wrong with saying I don't know.
My personal perspective is that we should all identify to some degree as either a theist agnostic or an atheist agnostic, but agnostic is the key word. Nobody knows. Richard Dawkins doesn't know. You don't know. I don't know. Nobody knows.
I could hug you right now.
But the thing is, getting back to the information, you were talking about the turtles and the numerous generations, and you could have 200 turtles and they're all coming from these ancestors. And my point is, in that 5th generation, you can look at any individual turtle, analyze its DNA, and go back up to the ancestral generation 5 generations previous. Turtles have DNA that's unique, just as humans do, just as plants do. Every organism on the earth has unique DNA that identifies its origin. And to me, in an unplanned world, we might get that first extremophile to form, and it be AC ATCG, whatever it is, and you get that combination 3.2 billion times, and it's ingrained in stone, if you will. It's not unique in that every iteration after that is going to have the same identical blueprint. But then at some point in time, we get to the point where it takes multiple individuals to produce offspring by recombination of genetic material. And so then it all boils down to the DNA inside of the cell. And what do we know about the DNA? We know that they can extract all of the genetic information out of a strain of DNA. They can encode the contents of a book into the DNA and then decode it. It's an information system. There's no two ways about it. And that's a very enlightening term in itself as well, in that information is not data. Information is processed. It's not useless. Useless data is everything in the universe just all thrown out there. Information is you take a subset of that universe of information and you turn it into something that's meaningful, that you are able to develop new ideas and new technology and new things from this existing base of information.
Right.
And to me, you don't get information without having raw data processed into output.
Right.
And that requires a system, and systems don't arise by chance. You've got an operating system in the computer. It's very precisely arranged bits of data and information that the
Yep.
computer is able to process. Everything
Yep.
in this world is built on that same model. It has that same paradigm of you've got all these raw materials, you've got iron
Yep.
and magnesium and calcium and all of these different materials that can be combined in certain combinations, and then you get a living organism from this unique combination. To me, all of this entire conversation that we've had tonight or this morning, this entire conversation is based on the principle of two people that consider themselves to be reasonably intelligent are communicating over this distance, but in a world where there is no controlling legal authority, there is no ultimate reason giving reason to our existence, then we're just literally organic bags of chemicals that code for protein. That's almost out of Susan Blackmore's playbook, but and I marvel at that because she says your life has no meaning, there is no purpose, but you should buy my book.
Okay. Yep. Okay. I think that as that's well put. Personally, I don't think that there is a higher purpose to life other than what we give it by instinct and possibly by reasoning. So, in that sense, I agree that are we bags of stuff that codes for protein? Yeah, we are. Does that mean that life is meaningless? And I go, no, hang on a second. Life is an ambiguous term. Is there meaning to the existence of life in the universe versus a universe that doesn't have any life in it? And I would say, no, there isn't a meaning to life on that level. The other level, is there a meaning to life, to the existence that we experience ourselves, to the fact that we experience ourselves as continuing minds that have a history and memories and futures and plans and feelings and instincts and loves and dislikes and all sorts of things. To that life, there is a meaning, and the meaning is what you define as meaning, what you experience as meaningful. To me, it's meaningful. I experience it as meaningful to be talking to you, for example. To me, that is a meaningful thing because I'm sharing something that has taken me time and work to arrive at, some conclusions that didn't just come to me one morning out of thin air. They are the result of years of thinking and coming back to it and then going away and coming back to it again. And I would like for that which inherently has value because it's somewhat unique in that other people might have similar conclusions, but not my conclusions and not my process. That makes it valuable. And I want to give that to you and to anybody else that cares to listen because I think that's a good thing to share. I certainly feel that I'm benefiting from getting your points of view. I've benefited from reading the God conclusion. And that was a valuable thing because it took you a long time to create that. That stuff doesn't just materialize of nowhere on a fine morning. It takes work. So I've had thoughts that I would never have had I not read the God conclusion. That's a benefit to me. I experience that as a good thing. Why is that a good thing? Can I give you a philosophical treatise why it is a good thing for me to be reading your thoughts? Not off the top of my head. I might be able to stretch to that, but to be honest with you, I'm quite happy to just go, yeah, it feels good. I feel enriched. I feel my life is better for having read the book. that makes it a meaningful thing to do.
I really appreciate you saying that. And I really value our friendship. Uh, I confess, when we started this conversation, I did not have high hopes that you were going to have this epiphany and say, I agree with everything that you say. But I have not been disappointed at all, because what I've encountered in this is a receptiveness to new ideas, to thinking outside of the established thought processes that we have that are ingrained in our everyday lives. And I do value the opportunity to sit here and have this conversation, which I promised you when we started, or before we started, that we should be done in an hour, and I see we're at an hour and a half now. So what I was going to suggest is that perhaps we bring it to an end here briefly, and then maybe take some time and think about the conversation and come back and do this again, because I have thoroughly enjoyed this. But I'm gonna as my final pitch to you for today is I'm gonna try to tie in the idea of morality into this conversation, in the organic bag of meat that's just coding for protein. In a world where that mentality reigns supreme, anybody can literally do anything to another person. In their mind, it brings them satisfaction to do this. You know, the German phrase Schadenfreude of enjoying misery at the expense of other people. People like to, atheists, I should say, like to say that Christians are not perfect. And my response to that is, you're not telling me anything I don't know. My favorite example of that is it's a guy that's in the United States. It's called the BTK killer. It stood for bind, torture, and kill. And this guy was a creep beyond compare. He would go into a house and he'd kill the whole family. And he would tie them up, he'd torture them, and he'd kill them. His name was Dennis Rader. And Dennis Rader was caught because he was the president of his Lutheran church. And he sent taunting letters to the police through the church's that were printed from the church's computer. And they were able to bring in the metadata and identify the church that it came from. And that led them to him as a suspect, and they caught him. But it was his arrogance. But the thing is, he called himself a Christian. He not only called himself a Christian, he was the president of his congregation. And he could murder people for the pleasure of it. To me, that boggles the mind, that to kill anything, any animal, even a housefly, without having a reason for doing it. If a housefly flies into my house, I go, you can bring in germs, you can bring in diseases and that kind of stuff. I'm going to get the swatter and I'm going to kill you. But if I'm outside flying around, I don't go with a can of Raid and just start spraying, trying to kill every fly that in the proximity. I don't understand the mentality of somebody who can take life so indiscriminately. But to me, there's an answer for that in my theological worldview, and that answer is free will. We have the ability, you and I both, to look at the exact same information and come up with different conclusions. And to me, that is a description of free will, that I don't have to do what you do just because you do it, and you don't have to do what I do for the same reasons. So I hate saying the atheists do that, because I realize I'm talking about you too, in one sense. But Some of my friends on the other side of the aisle like to talk about, they do the Hitler thing. They love him.
Yeah.
And to me, that boils down to the whole basis of the argument for morality. If there is no objective morality, if there is no God, Hitler wasn't wrong. Hitler was legal. He had all the authority in Germany to do anything that he did.
Legality and morality are two different things. Yes.
But legality stems or originated, it drew from morality. It was codified from morality.
Yes, correct.
And I love the joke of punctuation means everything. Let's eat, Grandma, versus let's eat, Grandma.
One of my favorites also, just saying, punctuation saves lives.
It does. So on that note, my friend, I'm going to suggest that we say good night or good morning for this call and take some time to reflect on this. And then, I'm looking forward to our next conversation already.
Look, so do I, and thank you for both suggesting this and to be willing to continue it. We have a lot of stuff that we haven't covered, including implications of morality and those considerations you've alluded to. Coming back to one small point you made earlier, you said it annoys you when people, scientists typically, or even non-scientists who rely on scientists, go, evolution is an established fact. It's just a fact. We know that. I get annoyed at that as well. And I think that's the other thing I'd like to pick up next time, which is epistemology. What does it mean that we know a thing? And I understand why people say we know evolution to be a fact. There are specific reasons why I really object to that phrasing in certain contexts. And it will be good to dive into that as well.
I look forward to it. Thank you again, Tony, and we'll talk soon.
Thank you, John. Let's line it up. Cool.
All right. Good night.
See ya. Bye.
Thank you for listening to The God Conclusion. If you like this episode, please consider subscribing to this channel. Join us again next week as we continue to seek truth. Quid est veritas.